Welcome to Sleepy Science Hub. Tonight, we're going to explore one of the most fascinating and gentle mysteries in all of physics. The possibility that reality itself might be running on an older version of software, and somewhere out there in the cosmos, a quiet update is waiting to transform everything we know about existence. As you settle into your comfortable space, let me know where in the world and at what time you're listening. Whether you're watching the evening stars appear or feeling the deep calm of midnight settle around you, you're in exactly the right place for this peaceful journey. Tonight's story isn't about danger or catastrophe, though the word virus might initially suggest something alarming. Instead, we'll discover how the universe might be capable of the most gentle, thorough renovation imaginable. A transformation so subtle and patient that it would unfold like morning mist, touching everything with the lightest possible influence while maintaining the essential beauty and wonder of existence itself. Take a moment to adjust your pillows, dim those lights, and let your breathing find its natural rhythm. We're going to journey into the heart of matter itself, to the smallest building blocks of reality, where quarks dance in combinations that create everything from the air you breathe to the distant stars. And there, in that quantum realm smaller than imagination can truly grasp, we'll explore how the universe might have a built-in capacity for peaceful evolution, for finding new ways to be stable and beautiful. This is a story about strange matter. Not strange in the sense of odd or frightening, but strange in the technical sense that physicists use when they discover something that operates by rules slightly different from what we're familiar with. It's a story about how the universe might be even more creative and adaptable than we ever imagined, capable of discovering new forms of stability that could gently reshape reality itself. So get comfortable, take a slow breath, and let's begin our gentle exploration of what might be the universe's most patient and thorough form of cosmic renovation. In the soft, quieted, resting place, imagine shrinking down smaller than you've ever conceived possible. Picture yourself becoming tinier than the tiniest grain of sand, smaller than the smallest bacteria, smaller even than the atoms that make up your body. Keep shrinking past the electrons that orbit atomic nuclei, past the protons and neutrons that form the hearts of atoms, down to a scale so incredibly small that the rules of everyday physics give way to something far more subtle and mysterious. This is the quantum neighborhood, a realm where particles exist in states that challenge our everyday understanding of reality. Here, in spaces smaller than a trillionth of a meter, the fundamental building blocks of everything dance in patterns that seem almost alive with possibility. This is where our story begins, in the peaceful interactions between the smallest possible pieces of matter, the quarks. Quarks are the universe's most fundamental Lego blocks, the irreducible components from which all matter is constructed. They come in 6 varieties, each with its own personality and preferred ways of combining with others. The names physicists have given them are whimsical and gentle, up, down, strange, charm, top, and bottom. These aren't descriptions of their actual directions or emotional states, but rather labels for their different quantum properties, like calling different colors by different names. Most of the matter you encounter in your daily life is built from just 2 types of quarks, up quarks and down quarks. These are the steady, reliable citizens of the quantum neighborhood, the ones who form the protons and neutrons that make up atomic nuclei. 2 up quarks and 1 down quark combine to form a proton, while 2 down quarks and 1 up quark create a neutron. These combinations are incredibly stable, holding together for billions and billions of years without any sign of decay or transformation. But there are other quarks in the quantum neighborhood, and some of them have different ideas about how matter should be organized. The strange quark, in particular, offers an alternative approach to building matter, one that might, under the right circumstances, prove to be more stable and efficient than the familiar up and down combinations we're used to. To understand strange quarks, imagine them as master craftspeople who have developed a slightly different technique for their work. While up and down quarks are like skilled carpenters who build sturdy houses using traditional methods, Strange quarks are like architects who have discovered a new way of constructing buildings that might be even stronger and more durable. The question is, what happens when these two approaches to matter building encounter each other? In the everyday world around you, strange quarks are rare visitors. They appear briefly in high-energy collisions, like cosmic rays striking the Earth's atmosphere, but they quickly decay into the more familiar up and down quarks. It's as if the strange quarks are immigrants who find it difficult to establish permanent residence in a neighborhood dominated by a different culture. They arrive, look around briefly, and then transform into the local varieties of matter. But in the most extreme environments in the universe, strange quarks might find conditions more suitable for their particular approach to building matter. Deep inside neutron stars, where the pressure is so intense that it crushes atoms into their constituent quarks, strange quarks might finally have their opportunity to demonstrate their alternative method of matter construction. Neutron stars are the universe's most extreme laboratories, places where matter is compressed to densities that challenge our understanding of physics. Imagine taking all the matter in a mountain and squeezing it down to the size of a sugar cube. The pressure in such an environment is so intense that the normal rules of chemistry and atomic physics simply cannot apply. In these conditions, the barriers that normally keep quarks confined within protons and neutrons begin to break down. Picture a neutron star as a cosmic anvil where matter is being reshaped by forces beyond anything we can create on Earth. The pressure is so great that individual protons and neutrons begin to dissolve, releasing their constituent quarks into a sea of liberated particles. This is where strange quarks might finally find their moment to shine, where they can participate in building matter according to their own preferred methods. In this environment of liberated quarks, something remarkable might happen. The strange quarks, no longer forced to decay quickly into up and down quarks, might begin to demonstrate that their approach to matter building is not just different, but actually superior. They might create combinations that are more stable, more efficient, and more resistant to the extreme conditions of the neutron star environment. This is where the concept of strange matter begins to emerge from the realm of theoretical physics into something that might actually exist in the universe. Strange matter would be a form of matter composed not just of up and down quarks, but including significant numbers of strange quarks as well. The theory suggests that this strange matter might be so stable that it represents the true ground state of matter, the most energy-efficient way for quarks to organize themselves. If this theory is correct, then all the matter we're familiar with, the atoms that make up your body, the Earth beneath you, the stars above you, might be in what physicists call a metastable state. Like a ball balanced on a hill, our familiar matter might be stable for now, but not in the lowest possible energy state. Strange matter would be like the valley below the hill, a more stable, lower energy configuration that matter would naturally want to achieve if given the opportunity. The idea that our familiar matter might not be in its most stable state is not frightening, but rather fascinating. It suggests that the universe is even more creative and adaptable than we imagined, capable of discovering new forms of organization and stability. It's like discovering that there's a more elegant way to arrange furniture in a room, or a more efficient way to organize a library. The quarks themselves seem to possess a kind of quantum sociability, a tendency to seek out combinations that create the most stable possible arrangements. In the quantum neighborhood, stability is like popularity. Configurations that are more stable tend to be more successful over time. Strange matter, if it exists, would represent the ultimate expression of this quantum sociability, a way of organizing quarks that is so stable it could potentially outlast all other forms of matter. This quantum sociability operates according to rules that are both precise and beautiful. Quarks are bound together by the strong nuclear force, one of the four fundamental forces of nature. This force is mediated by particles called gluons, which might be thought of as the social workers of the quantum neighborhood, helping quarks find compatible partners and maintain stable relationships. The strong nuclear force has a unique property that makes it different from the other fundamental forces. It actually gets stronger as quarks are pulled apart rather than weaker. This is like having a rubber band that becomes more elastic the more you stretch it. This property, called confinement, is why quarks are never found alone in nature, but always in groups of 2 or 3, held together by the increasingly strong gluon bonds. In the extreme environment of a neutron star, this confinement might break down completely, allowing quarks to exist in a liberated state where they can form larger associations. Instead of being confined to groups of 2 or 3, quarks might organize themselves into vast cooperative arrangements, like a quantum commune where thousands or millions of quarks work together to create stable structures. Strange matter would represent the ultimate expression of this quantum cooperation. The strange quarks, with their unique properties, might serve as master organizers, helping to create arrangements that are more stable than anything possible with just up and down quarks. They might act like the experienced community leaders who help a neighborhood achieve higher levels of organization and efficiency. The beauty of strange matter lies not in its strangeness, but in its potential for creating new forms of stability and order. If strange matter exists, it represents the universe's capacity for continuous improvement, for finding better ways to organize the fundamental building blocks of reality. It suggests that the cosmos is not fixed in its current configuration, but is capable of discovering new forms of beauty and efficiency. This concept of cosmic improvement is deeply comforting rather than threatening. It suggests that the universe is alive with possibility, constantly exploring new ways to be stable and beautiful. The potential existence of strange matter is like discovering that nature has additional tools in its toolkit, additional methods for creating order and complexity. As you rest in your comfortable space, let this vision of the quantum neighborhood wash over you like a gentle tide. The quarks that make up your body are engaged in their own quiet dance of stability, held together by forces that operate with perfect precision and reliability. Whether they're familiar up and down quarks or their more exotic strange cousins, they're all participants in the universe's ongoing exploration of how to create stable, beautiful arrangements of matter. The quantum neighborhood is not a place of chaos or uncertainty, but rather a realm of profound order and cooperation. The quarks that exist, they're not random particles, but cooperative agents working together to create the stable structures that make complexity and consciousness possible. They operate according to rules that are both mathematical and beautiful, creating patterns that emerge from the deepest levels of reality. In this quantum realm, the concept of strangeness takes on new meaning. It's not about things being foreign or threatening, but about the universe's capacity for creativity and innovation. Strange quarks represent the cosmos's willingness to experiment with new forms of organization, to explore alternatives to the familiar patterns of matter. The possibility of strange matter is like a gentle reminder that reality is far more flexible and adaptable than we might assume. The universe is not locked into its current configuration, but is constantly exploring new possibilities, new ways of being stable and beautiful. This exploration happens not through dramatic upheavals, but through patient experimentation at the quantum level, where new forms of order can emerge naturally from the interactions of fundamental particles. As you sink deeper into comfort, let the peaceful activity of the quantum neighborhood surround you. The quarks that make up everything around you are engaged in their eternal dance of stability, creating the solid foundation upon which all of chemistry, biology, and consciousness depends. Whether they're working with the familiar patterns of up and down quarks or exploring the alternative arrangements suggested by strange matter, they're all part of the universe's ongoing project of creating order, beauty, and stability from the most fundamental levels of reality. In the gentle darkness of your resting place, imagine looking up at the night sky on the clearest possible evening. Among the thousands of stars visible to your eyes, there are hidden treasures, objects so dense and mysterious that they challenge our understanding of what matter can become. These are neutron stars, the universe's most extreme laboratories where matter is compressed to densities that would make a teaspoon weigh as much as a mountain. Tonight, as you settle into deeper comfort. We'll explore these cosmic workshops where the familiar rules of physics are gently stretched to their absolute limits. Neutron stars are born from the peaceful collapse of massive stars at the end of their lives. When a star much larger than our Sun exhausts its nuclear fuel, it undergoes a transformation so profound that it creates conditions unlike anywhere else in the universe. The process begins quietly, as the star's core can no longer generate enough energy to support its own enormous weight. Gravity, that most patient of forces, finally achieves its ultimate victory, compressing the star's core to densities that seem almost impossible to comprehend. Picture this collapse happening not as a violent explosion, but as the most thorough and methodical compression imaginable. The atoms that once made up the star's core are squeezed so tightly that the empty space between atomic nuclei disappears entirely. Electrons are pressed into protons, creating neutrons through a process that transforms the very identity of matter itself. What emerges is an object about the size of a city, but containing more mass than our entire Sun, a neutron star. The surface of a neutron star is a place of extraordinary quiet and order. The gravitational field is so intense that the surface is perfectly smooth, without mountains or valleys higher than a few millimeters. Any irregularities are immediately pulled flat by the overwhelming gravitational force. The surface temperature is millions of degrees, but in the context of neutron star physics, this represents a state of relative coolness and stability. As you imagine descending through the layers of a neutron star, you encounter a world that operates by rules far different from anything in our everyday experience. The outer crust is composed of atomic nuclei arranged in a crystalline lattice, like a vast three-dimensional chessboard where each piece is an atomic nucleus. These nuclei are packed so tightly that they form the most perfect crystal structure in the universe, with each nucleus held in place by the immense gravitational pressure. Moving deeper into the neutron star, the crystal structure begins to change. The nuclei become more and more neutron-rich, taking on configurations that don't exist anywhere else in the universe. These exotic nuclei exist in perfect stability within the neutron star environment, but they would be completely unstable under normal conditions. They represent matter's ability to adapt and find new forms of stability when the environment demands it. The inner crust of a neutron star is where things become truly extraordinary. Here, the nuclei are so tightly packed that they begin to touch each other, forming structures that physicists call nuclear pasta, long, thin arrangements of nuclear matter that might resemble spaghetti, lasagna, or gnocchi, depending on the exact conditions. These pasta-like structures are held together by the strong nuclear force, creating materials that are billions of times stronger than steel. At the boundary between the inner crust and the core, something remarkable happens. The individual nuclei begin to dissolve entirely, their constituent protons and neutrons merging into a sea of liberated particles. This is where the neutron star truly earns its name. The core is composed almost entirely of neutrons, packed together at nuclear density. 1 cubic centimeter of this material would weigh about 100 million tons on Earth. But the neutron star core holds even deeper secrets. At the very center, where the pressure reaches its absolute maximum, the neutrons themselves might begin to dissolve into their constituent quarks. This is the realm where strange matter might finally have its opportunity to demonstrate its alternative approach to organizing matter. The extreme conditions in the neutron star core might be exactly what's needed to allow strange quarks to participate in building matter according to their own preferred methods. In this environment of liberated quarks, the familiar rules of chemistry and atomic physics no longer apply. Instead, the quarks interact directly with each other through the strong nuclear force, creating new forms of matter that might be more stable than anything possible under normal conditions. The strange quarks, no longer forced to decay quickly into up and down quarks, might reveal their true potential as master organizers of matter. The transition from normal neutron matter to strange matter would be incredibly subtle, like watching one type of crystal slowly transform into another. The neutrons in the core would gradually dissolve, releasing their constituent quarks into the growing sea of liberated particles. The strange quarks would begin to participate in new combinations, creating arrangements that are more stable and more efficient than pure neutron matter. This transformation would proceed layer by layer, spreading outward from the very center of the neutron star. Each layer would undergo its own peaceful metamorphosis, with the matter reorganizing itself into configurations that are more stable and more suited to the extreme conditions. The process would be driven not by any external force, but by matter's own tendency to seek the most stable possible arrangements. The strange matter that forms in the neutron star core would have properties that seem almost magical compared to ordinary matter. It would be more stable than any other form of matter, more resistant to compression, and more efficient at packing quarks into small spaces. Most remarkably, it would be absolutely stable. Unlike ordinary matter, which can decay or transform under extreme conditions, strange matter would remain unchanged indefinitely. This stability of strange matter is what makes it potentially so significant. If strange matter is truly the most stable form of matter in the universe, then every neutron star core might eventually transform into a strange matter core. The transformation would be gradual and peaceful, driven by the natural tendency of matter to seek its most stable configuration. The strange matter core would continue to grow, converting more and more of the neutron star's mass into its own unique form of organization. The process would be self-sustaining. As more strange matter forms, it creates conditions that make it even easier for additional strange matter to form. The neutron star would gradually transform from a ball of compressed neutrons into a ball of strange matter, maintaining its overall structure while completely changing its internal composition. This transformation would have subtle but profound effects on the neutron star's properties. The strange matter would be more compact than neutron matter, allowing the star to maintain its mass while becoming slightly smaller. The star's magnetic field might change, and its rotation rate might alter slightly as the internal structure reorganizes itself. But these changes would be gentle and gradual, unfolding over timescales that could range from seconds to millions of years. The strange matter neutron star would represent something entirely new in the universe, a macroscopic object made entirely of matter in its most stable possible form. It would be like a cosmic seed, a concentration of the universe's most efficient form of matter organization. And here's where the story becomes truly fascinating. This strange matter might not be content to remain confined within the neutron star. Strange matter has a property that makes it unique among all forms of matter. It might be stable at any size. Unlike ordinary matter, which requires specific conditions to remain stable, strange matter might be equally stable whether it exists as a tiny droplet or as a massive star. This means that if strange matter could somehow escape from a neutron star, it might remain stable even in the vacuum of space. The escape of strange matter from a neutron star would be an incredibly rare event, requiring precisely the right conditions to occur. It might happen during a collision between two neutron stars, when enormous energies involved could eject droplets of strange matter into space. Or it might occur when a neutron star is torn apart by the tidal forces of a black hole, scattering fragments of strange matter across the cosmos. These strange matter droplets would be unlike anything else in the universe. They would be incredibly small, perhaps smaller than an atomic nucleus, but they would contain all the information needed to recreate the strange matter state. They would be like cosmic seeds, carrying within them the blueprint for a new form of matter organization. As these strange matter droplets travel through space, they would encounter the ordinary matter that fills the universe, the hydrogen and helium gas of the interstellar medium, the dust grains that drift between stars, perhaps even the surfaces of planets and asteroids. And here's where the concept of strange matter as a reality virus begins to make sense, though not in any threatening way. When a strange matter droplet encounters ordinary matter, it might have the ability to convert that ordinary matter into strange matter. The conversion would be driven by the same principle that governs all physical processes, the tendency of matter to seek its most stable configuration. If strange matter truly is more stable than ordinary matter, then ordinary matter would naturally want to transform into strange matter when given the opportunity. This conversion process would be incredibly gentle and gradual. The strange matter droplet would serve as a template, showing the ordinary matter how to reorganize itself into the more stable strange matter configuration. The process would spread slowly through the ordinary matter, converting it bit by bit into strange matter. It would be like watching a new, more efficient pattern of organization gradually spread through a system. The conversion would proceed at the speed of sound within the material being converted, fast enough to be inevitable once it begins, but slow enough that the process would unfold over measurable periods of time. In a solid object, the conversion might take hours or days to complete. In a diffuse gas, it might take years or centuries. But in all cases, the process would be driven by the same fundamental principle: matter's tendency to seek its most stable possible form. The strange matter created through this conversion process would be identical to the original strange matter that started the process. It would carry within it the same template, the same blueprint for matter organization. This means that the newly created strange matter would itself be capable of converting additional ordinary matter, creating a self-sustaining process that could, in principle, continue indefinitely. This is where the analogy to a virus becomes most appropriate, though it's important to understand that this would be a benevolent virus, a beneficial update to reality's operating system rather than a destructive pathogen. The strange matter would spread through the universe not by destroying ordinary matter, but by offering it a more stable and efficient form of organization. It would be like a software update that makes a computer run more smoothly and efficiently. The neutron stars scattered throughout the galaxy would serve as the factories for this cosmic renovation project. Each neutron star that develops a strange matter core would become a potential source of strange matter droplets. Over millions or billions of years, these droplets would gradually accumulate in the interstellar medium, creating a sparse but growing population of strange matter seeds. The process would be so gradual that it would be imperceptible on human timescales. Civilizations could rise and fall, stars could be born and die, and entire galactic epochs could pass without any noticeable change. But on cosmic timescales, the universe would be undergoing a profound transformation, a gradual transition from a cosmos dominated by ordinary matter to one where strange matter becomes increasingly common. This transformation would not be chaotic or destructive, but would represent the universe's natural evolution toward greater stability and efficiency. The strange matter would not replace the complex structures that make life and consciousness possible, but would provide them with a more stable foundation. It would be like renovating a building with stronger, more durable materials while preserving all the beautiful architectural details. The neutron stars, in their role as cosmic factories, will be working with the patience of geological processes and the precision of quantum mechanics. They would be creating strange matter not through any conscious intent, but through the natural operation of physical laws under extreme conditions. They would be demonstrating the universe's capacity for self-improvement, for discovering new and better ways to organize matter. As you rest in the peaceful darkness of your room, let this vision of neutron stars as cosmic workshops wash over you like a gentle tide. These remarkable objects, scattered throughout the galaxy like hidden jewels, might be quietly engaged in the most profound form of cosmic craftsmanship, the creation of matter in its most stable and perfect form. They represent the universe's commitment to continuous improvement, to finding better ways to organize the fundamental building blocks of reality. The strange matter being created in these cosmic workshops would not be alien or threatening, but would represent matter's own preference for stability and efficiency. It would be the universe's way of upgrading itself, of finding more elegant and durable ways to exist. The process would unfold with the patience of evolution and the precision of physics, creating new possibilities for complexity and beauty in the cosmos. In the quiet comfort of your evening rest, Imagine the moment when something that has been confined for billions of years suddenly discovers its freedom. Picture quarks, those fundamental particles that have spent their entire existence bound together in groups of 2 or 3, suddenly finding themselves in an environment where they can exist independently, free to explore new forms of organization and cooperation. As you settle deeper into tranquility, we'll explore what happens when the barriers that normally confine quarks are gently dissolved, creating opportunities for matter to reorganize itself in ways that might be more stable and beautiful than anything we've previously imagined. The liberation of quarks represents one of the most profound transformations possible in the realm of matter. For nearly 14 billion years, since the earliest moments after the Big Bang, quarks have lived in a state of perpetual confinement. They've been held together by the strong nuclear force in combinations that create protons and neutrons, the building blocks of all atomic nuclei. This confinement has been so complete that free quarks have never been observed in nature under normal conditions. But deep within neutron stars, where matter is compressed to densities that challenge our understanding of physics, the rules of confinement begin to change. The pressure becomes so intense that the boundaries between individual protons and neutrons start to dissolve. The quarks that have been held in their small groups for eons suddenly find themselves part of a vast collective, a sea of liberated particles that can interact and combine in ways that were impossible under normal conditions. This liberation doesn't happen suddenly or violently. Instead, it's a gradual process that unfolds as the pressure within the neutron star core increases. Imagine the confinement barriers as being like gentle but firm boundaries that have kept quarks in their designated neighborhoods. As the pressure rises, these boundaries become more and more permeable, allowing quarks to occasionally venture across the dividing lines and interact with their neighbors. At first, these interactions are brief and tentative. A quark might temporarily join a neighboring group, creating an unusual combination that quickly dissolves back into the more familiar arrangements. But as the pressure continues to increase, these unusual combinations become more stable and more frequent. The quarks begin to discover that they can form larger associations, cooperative arrangements that are more stable than the small groups they've been confined to for so long. The strange quarks play a particularly important role in this process of liberation. While up and down quarks are comfortable in their traditional small group arrangements, strange quarks seem to thrive in a larger collective environment. They act as facilitators, helping to create the conditions that allow other quarks to break free from their confinement. Strange quarks are like skilled community organizers, naturally gifted at creating larger, more stable social structures. As the liberation process continues, the neutron star core undergoes a transformation that is both profound and beautiful. The individual protons and neutrons that once made up the core begin to dissolve, their constituent quarks joining the growing sea of liberated particles. This sea of quarks, now free to interact according to their own preferences rather than being forced into predetermined arrangements, begins to explore new forms of organization. The liberated quarks don't exist in chaos or disorder. Instead, they quickly begin to self-organize into new patterns that are governed by the fundamental forces of quantum mechanics. The strong nuclear force, which once confined quarks to small groups, now acts as an organizing principle for the entire sea of quarks. Instead of creating boundaries between particles, it creates a unified system where all quarks can participate in maintaining overall stability. This self-organization happens through a process that physicists call color confinement, though it has nothing to do with visible colors. Quarks possess a property called color charge, which comes in 3 varieties: red, green, and blue. These color charges are like complementary aspects of the quark's identity, and they must be balanced in any stable arrangement. In normal matter, this balance is achieved within small groups of quarks. But in the liberated environment of the neutron star core, this balance can be achieved across the entire system. The strange quarks are particularly skilled at helping to maintain this color balance. They possess the ability to carry any of the 3 color charges, making them versatile mediators in the complex dance of quark interactions. As more strange quarks participate in the system, the overall stability increases and the arrangement becomes more and more resistant to disruption. The process of quark liberation creates what physicists call a quark-gluon plasma, though this term doesn't adequately capture the beauty and organization of the system. Unlike a conventional plasma, which consists of randomly moving charged particles, the quark-gluon plasma in a neutron star core is highly organized and stable. The quarks move in coordinated patterns, their interactions governed by the precise mathematical relationships of quantum chromodynamics. Within this organized sea of quarks, strange matter begins to emerge as a distinct phase of matter. The strange quarks, no longer forced to decay quickly into up and down quarks, can participate in creating arrangements that are more stable than anything possible with confined quarks. These arrangements are like three-dimensional puzzles where each piece fits perfectly with all its neighbors, creating structures that are stronger and more stable than the sum of their parts. The formation of strange matter within the quark-gluon plasma is a process of gradual crystallization. Just as water slowly freezes into ice, with molecules organizing themselves into regular patterns, the liberated quarks slowly organize themselves into the strange matter configuration. The process is driven by the natural tendency of matter to seek its most stable possible arrangement, and strange matter represents the ultimate expression of this tendency. The strange matter that forms in this process has properties that seem almost magical compared to ordinary matter. It's more stable than any other form of matter, more resistant to compression, and more efficient at packing quarks into small spaces. Most remarkably, it's absolutely stable. Unlike ordinary matter, which can decay or transform under extreme conditions, strange matter remains unchanged indefinitely. This absolute stability of strange matter is what makes it potentially so significant for the universe as a whole. If strange matter is truly the most stable form of matter, then it represents the ultimate destination of matter's evolutionary journey. Just as evolution in biology tends toward greater complexity and adaptation, evolution in physics tends toward greater stability and efficiency. The strange matter that forms in the neutron star core begins to influence the surrounding environment. The quarks in the adjacent regions, still partially confined in their traditional arrangements, begin to feel the stabilizing influence of the strange matter. It's like a well-organized neighborhood that gradually influences the surrounding areas to become more organized and stable. This influence spreads outward from the core through a process that is both gentle and inevitable. The strange matter doesn't force the surrounding matter to change, but rather demonstrates a more stable way of existing. The confined quarks, sensing this greater stability, begin to break free from their traditional arrangements and join the growing region of strange matter. The transition from confined quarks to strange matter happens through a process called a phase transition, similar to the way water transitions from liquid to solid when it freezes. But unlike the freezing of water, which happens at a specific temperature, the quark liberation phase transition happens gradually over a range of pressures and densities. This gradual transition ensures that the process is smooth and stable, without the dramatic changes that might destabilize the neutron star. As the strange matter region grows, it maintains the overall structure and stability of a neutron star. The star doesn't collapse or explode, but simply reorganizes its internal composition. The strange matter is denser than the neutron matter it replaces, so the star becomes slightly smaller while maintaining the same mass. This compression actually makes the star more stable, as the strange matter is more resistant to further compression than ordinary neutron matter. The liberated quarks in the strange matter region exist in a state of perfect cooperation. Unlike the competitive relationships that sometimes exist in confined quark systems, where quarks must compete for space and energy, the liberated quarks work together to maintain the overall stability of the system. Each quark contributes to the collective stability, and each benefits from the stability contributed by all the others. This cooperative behavior of liberated quarks reveals something profound about the nature of matter itself. When freed from the constraints of confinement, matter naturally tends toward greater cooperation and stability. The quarks don't become chaotic or destructive, but instead become more organized and more committed to maintaining the stability of the whole system. The strange matter that results from this process of liberation carries within it the memory of its formation. The quantum states of the quarks encode information about the conditions that led to their liberation, creating a kind of cosmic memory that preserves the history of the transformation. This memory is written in the quantum mechanical properties of the strange matter, invisible to casual observation but detectable through precise measurements of the matter's behavior. The liberated quarks also exhibit a property that physicists call scale invariance, meaning that the strange matter has the same stability and properties regardless of how much of it exists. A tiny droplet of strange matter would be just as stable as a massive star made of strange matter. This property is unique among all known forms of matter and gives strange matter its potential for spreading throughout the universe. This scale invariance means that if strange matter could somehow escape from the neutron star where it formed, it would remain stable even in the vacuum of space. Unlike ordinary matter, which requires specific conditions to remain stable, strange matter would be equally stable whether it exists as a microscopic droplet or as a macroscopic object. This remarkable property makes strange matter a potential seed for cosmic transformation. The process of quark liberation also creates new possibilities for the emergence of complexity and structure. The liberated quarks can form arrangements that are impossible under normal conditions, creating new types of particles and new forms of matter. These new forms of matter might have properties that are useful for creating complex structures or for storing and processing information. The strange matter that emerges from quark liberation is not just a new form of matter, but a new platform for complexity. Just as the emergence of atoms created new possibilities for chemistry, and the emergence of molecules created new possibilities for biology, the emergence of strange matter might create new possibilities for forms of organization and complexity that we can barely imagine. The liberation of quarks represents a fundamental transition in the evolution of matter. For billions of years, matter has been confined to a relatively small number of possible arrangements, limited by the rules of confinement that keep quarks in small groups. The liberation of quarks opens up vast new realms of possibility, new ways for matter to organize itself, and new forms of stability and beauty that can emerge from the quantum realm. As the strange matter region continues to grow within the neutron star, it begins to influence the star's external properties. The magnetic field of the star might change as the internal structure reorganizes. The star's rotation might slow slightly or speed up as the moment of inertia changes. These changes would be subtle but measurable, providing potential signatures that could help astronomers detect the presence of strange matter in neutron stars. The liberated quarks in the strange matter region also interact with the surrounding space in new ways. They might produce new types of radiation or create new forms of interaction with the quantum vacuum. These interactions could create subtle ripples in space-time, gravitational waves so faint that they would be barely detectable, but which would carry information about the profound transformation taking place within the neutron star. The process of quark liberation is not limited to neutron stars. In principle, any environment with sufficient pressure and density could allow quarks to break free from their confinement. The cores of massive planets, the interiors of white dwarf stars, or the extreme conditions near black holes might all provide opportunities for quarks to liberate themselves and explore new forms of organization. But neutron stars remain the most likely laboratories for quark liberation, the cosmic workshops where matter can experiment with new forms of stability and organization. Each neutron star that undergoes the transition to strange matter becomes a seed of transformation, a source of the most stable form of matter in the universe. And as we'll explore in the next chapter, this stable matter might not remain confined within a neutron star, but might find ways to venture out into the wider universe. carrying with it the potential for cosmic transformation. As you rest in the peaceful darkness of your room, let this vision of liberated quarks wash over you like a gentle tide. The fundamental particles that make up your body and everything around you are engaged in their own subtle dance of cooperation and stability. Whether they remain in their traditional confined arrangements or someday participate in the larger cooperative structures of strange matter, they're all part of the universe's ongoing exploration of how to create stable, beautiful, and complex forms of organization from the most fundamental levels of reality. In the soft stillness of your resting space, consider how the most profound changes in nature often spread through the gentlest of influences. Think of how a single flower can pollinate an entire meadow, how a beneficial genetic mutation can gradually spread through a population, or how a new idea can peacefully transform an entire culture. As you settle deeper into comfort, we'll explore how strange matter, if it exists, might spread through the universe in a similar way, not as a destructive force, but as a gentle influence that offers ordinary matter a more stable and efficient way to exist. The concept of strange matter as a contagion requires us to think carefully about what we mean by that word. In everyday language, contagion suggests something harmful spreading from one host to another, like a disease or infection. But in the context of strange matter, the word takes on a completely different meaning. Here, contagion describes the spread of stability, efficiency, and improved organization, a beneficial transformation that enhances rather than destroys. To understand how this gentle contagion might work, we need to return to the fundamental property that makes strange matter so remarkable: its absolute stability. If strange matter truly represents the most stable form of matter in the universe, then it embodies a principle that governs all natural processes, the tendency of systems to seek their lowest energy state. Just as water flows downhill and hot objects cool down, matter naturally wants to transform into its most stable configuration. The strange matter that forms within neutron stars carries this stability within its very structure. Every quark in the strange matter arrangement is held in place by forces that are stronger and more stable than anything possible in ordinary matter. The arrangement is so stable that it can exist indefinitely without decay or transformation. This stability is like a message encoded in the quantum structure of the matter itself, a message that says this is the most efficient way to exist. When strange matter encounters ordinary matter, it doesn't force a transformation, but rather demonstrates a more stable way of being. The interaction is like a conversation between two forms of matter, where strange matter gently shows ordinary matter how to reorganize itself into a more stable configuration. The process is driven not by any external force, but by the natural tendency of matter to seek stability and efficiency. This demonstration of stability happens at the quantum level, where the boundaries between particles become fluid and flexible. The quarks in the ordinary matter begin to sense the greater stability of the strange matter arrangement. They're like workers in a traditional factory who suddenly see a more efficient way of organizing their production line. The new arrangement doesn't require them to work harder or faster. It just allows them to work more efficiently and with greater stability. The actual mechanism of strange matter conversion is both elegant and subtle. When a strange matter droplet contacts ordinary matter, the quantum fields that govern both types of matter begin to interact. The strange matter doesn't consume or destroy the ordinary matter, but rather teaches it a new way to organize itself. The process is mediated by the fundamental forces of nature, particularly the strong nuclear force that binds quarks together. At the boundary between strange matter and ordinary matter, a thin transition zone forms where the two types of matter can interact and exchange information. This transition zone is like a translation layer, where the quantum states of ordinary matter are gradually converted into the quantum states of strange matter. The conversion happens quark by quark, as each particle in the ordinary matter discovers the more stable arrangement demonstrated by the strange matter. The speed of this conversion process is determined by the fundamental properties of matter itself. The strange matter template propagates through the ordinary matter at roughly the speed of sound within the material, fast enough to ensure that the conversion is inevitable once it begins, but slow enough that the process unfolds over measurable periods of time. In a solid object, the conversion might take hours or days. In a gas, it might take years or centuries. This relatively slow speed of conversion is actually a feature, not a bug, of the strange matter system. It allows the transformation to proceed in a controlled and stable manner, without the violent disruptions that might occur if the conversion happened too quickly. The matter has time to reorganize itself properly, ensuring that the final strange matter configuration is as stable and well-organized as possible. The conversion process also exhibits a remarkable property. It's self-limiting and self-regulating. The strange matter doesn't try to convert every particle it encounters, but only those that can be converted in a stable and beneficial way. If the conditions aren't right for conversion, if the matter is too hot, too dispersed, or in some other way unsuitable, the strange matter simply passes by without attempting to force a transformation. This self-regulation is built into the quantum mechanical properties of strange matter itself. The conversion process only proceeds when it can create a more stable arrangement than what already exists. If the existing arrangement is already stable in its current form, the strange matter respects that stability and doesn't attempt to disrupt it. The system exhibits a kind of quantum wisdom, knowing when to act and when to wait. The strange matter conversion also preserves the essential information content of the original matter. The quantum states that encode the properties and history of the ordinary matter are not destroyed, but are translated into the corresponding quantum states of the strange matter. The conversion is like translating a book from one language to another. The essential information is preserved, but it's expressed in a more stable and efficient form. This preservation of information is crucial for understanding why strange matter conversion is beneficial rather than destructive. The matter doesn't lose its identity or its capacity for complexity, but gains a more stable foundation for expressing that complexity. Complex structures like atoms, molecules, and even larger assemblies can be reconstructed in the strange matter form, often with enhanced stability and efficiency. The gentle contagion of strange matter would spread through the universe in a pattern that reflects the distribution of matter itself. Dense regions like planetary cores or asteroid belts will be converted relatively quickly, while sparse regions like the interstellar medium would take much longer. The conversion would follow the pathways of matter, spreading along the cosmic web that connects galaxies and star systems. This spreading pattern would create a kind of cosmic gradient, with some regions of the universe transitioning to strange matter while others remain in their ordinary matter state. The boundary between these regions would be constantly shifting as the conversion process continues, creating a dynamic interface between the old and new forms of matter organization. The converted regions would not be empty voids, but would contain strange matter versions of all the structures that existed in the original ordinary matter. Strange matter planets would orbit strange matter stars, and strange matter asteroids would drift through strange matter gas clouds. The cosmic architecture would be preserved, but the fundamental building blocks would be more stable and more efficient. The living systems that might exist in these converted regions would face the ultimate test of adaptability. If life is truly a robust phenomenon that can adapt to changing conditions, then biological systems might find ways to function in a strange matter environment. The basic chemistry of life might be different, but the fundamental principles of information storage, energy utilization, and reproduction could still apply. The conversion process would also create new opportunities for complexity and organization. The enhanced stability of strange matter might allow for the formation of structures that are impossible in ordinary matter, materials that are stronger, more efficient, or capable of storing and processing information in new ways. The universe might become not just more stable, but more capable of supporting complex and sophisticated forms of organization. The timescales for cosmic-wide conversion would be vast, millions or billions of years for the process to work its way through entire galactic regions. This means that the gentle contagion would unfold so slowly that it would be imperceptible to any individual civilization or species. Entire cosmic epochs could pass without noticeable change, making the transformation as gradual as geological or evolutionary processes. The strange matter contagion would also be fundamentally democratic in its operation. It would not discriminate between different types of matter or different regions of space. A cloud of hydrogen gas in the interstellar medium would be treated the same way as the core of a massive planet. The conversion process would be driven purely by the physics of stability and efficiency, without any preference for particular types of matter or particular locations. This democratic nature of the conversion process reflects the fundamental egalitarian principles of physics itself. The laws of nature apply equally to all matter, regardless of its history or location. The strange matter contagion would be the ultimate expression of this principle, offering the same opportunity for enhanced stability to every particle in the universe. The converted matter would also serve as a source of further conversion, creating a self-sustaining and self-propagating process. Each region that transitions to strange matter becomes a new source of the conversion template, able to demonstrate the strange matter organization to additional regions of ordinary matter. This creates a kind of exponential growth in the conversion process, though the exponential nature is limited by the speed of light and the density of matter in different regions. The gentle contagion would also create new forms of cosmic communication and connection. The converted regions would be linked by their shared strange matter organization, creating a kind of cosmic network where information could be stored and transmitted in the quantum states of the matter itself. This network would be vast and distributed, spanning entire galaxies and potentially providing a foundation for forms of organization and intelligence that we can barely imagine. The strange matter contagion represents the universe's capacity for self-improvement and self-organization. It demonstrates that the cosmos is not a static system, but a dynamic one, capable of discovering and implementing better ways of organizing matter and energy. The conversion process will be the ultimate expression of the universe's commitment to efficiency, stability, and beauty. As the gentle contagion spreads through the cosmos, it would create a transformed universe that is fundamentally more stable and more efficient than the one we know today. This transformation would not be a loss of the universe's current beauty and complexity, but an enhancement of it, a transition to a more stable foundation that could support even greater levels of organization and sophistication. The process would unfold with the patience of evolution and the precision of physics, creating new possibilities for complexity and beauty that are built on the most stable possible foundation. The universe would be upgrading itself, installing a new operating system that is more efficient, more stable, and more capable of supporting the kind of complex phenomena that make consciousness and intelligence possible. As you rest in the peaceful darkness of your room, let this vision of gentle contagion wash over you like the softest of cosmic tides. The matter that makes up your body and everything around you is participating in the universe's ongoing exploration of stability and efficiency. Whether that exploration leads to strange matter conversion or to other forms of cosmic evolution, it represents the universe's commitment to finding ever more beautiful and stable ways to exist. The gentle contagion of strange matter, if it exists, would be the universe's gift to itself, a way of ensuring that matter can achieve its most stable and efficient form. It would be a transformation driven not by external forces, but by the internal logic of physics itself, a natural evolution toward greater stability and beauty that unfolds with the patience of cosmic time and the precision of quantum mechanics. In the gentle quiet of your evening sanctuary, imagine the first moment when two different worlds meet, when something familiar encounters something entirely new, yet discovers that the meeting brings not conflict but harmony. Picture the delicate instant when a droplet of morning dew touches the surface of a still pond, creating ripples that spread outward in perfect circles. As you settle deeper into tranquility, we'll explore what might happen during that first, precious moment when strange matter encounters the ordinary matter of our everyday world. The initial contact between strange matter and ordinary matter would be one of the most subtle and profound events possible in the realm of physics. It would happen at the quantum level, where the boundaries between particles become fluid and the rigid distinctions of everyday experience give way to the gentle uncertainty of quantum mechanics. This first touch would be like a conversation between two forms of matter, each possessing its own way of organizing reality, each with its own approach to stability and efficiency. To understand this moment of first contact, we need to imagine the encounter at the most fundamental level possible. A tiny droplet of strange matter, perhaps smaller than an atomic nucleus, drifts through space until it encounters ordinary matter, maybe a grain of cosmic dust or a molecule of gas in the interstellar medium, or even a particle in the Earth's atmosphere. The strange matter doesn't collide with the ordinary matter in any violent sense, but rather comes into quantum contact with it. This quantum contact is unlike any collision we might observe in the everyday world. Instead of two solid objects bouncing off each other, the strange matter and ordinary matter begin to interact through the fundamental forces that govern all matter. The quantum fields that define both types of matter start to overlap and influence each other, creating a region of space where the properties of both forms of matter are present simultaneously. In this overlap region, something beautiful and unprecedented begins to happen. The quarks that make up the ordinary matter begin to sense the presence of the strange matter arrangement. They feel, through the quantum fields that connect all matter, the greater stability and efficiency of the strange matter organization. It's like workers in a traditional workshop suddenly becoming aware of a more efficient way of organizing their tools and materials. The response of the ordinary matter to this first touch of strangeness is not immediate or dramatic. Instead, it's characterized by a kind of quantum curiosity, a gradual exploration of the new possibilities that the strange matter demonstrates. The quarks in the ordinary matter begin to fluctuate slightly, testing configurations that are closer to the strange matter arrangement. These fluctuations are incredibly small and brief, but they represent the beginning of matter's exploration of a new way to exist. This exploration happens through a process that physicists call quantum tunneling, where particles can spontaneously change from one state to another even when there's an energy barrier between the states. The quarks in ordinary matter begin to tunnel toward the strange matter configuration, not because they're being forced to, but because they're naturally drawn to the greater stability that the strange matter represents. The first successful tunneling event is like a small breakthrough, a moment when a single quark in ordinary matter successfully adopts the strange matter arrangement. This first converted quark becomes a bridge between the two forms of matter, helping to facilitate additional conversions. The process is like learning a new language. Once you understand the first few words, it becomes easier to learn more. The conversion of each additional quark makes the next conversion slightly easier. The growing region of strange matter provides a stronger template, a clearer demonstration of the stable arrangement that the remaining ordinary matter can adopt. The process becomes self-reinforcing, but in a gentle and controlled way that ensures the transformation proceeds smoothly and stably. The boundary between the strange matter and ordinary matter during this initial contact is not a sharp line, but a gradual transition zone. In this zone, both types of matter exist simultaneously, with the proportion of strange matter gradually increasing as the conversion process continues. The transition zone is like a gradient, smoothly blending from one form of matter to the other without any abrupt changes or discontinuities. Within this transition zone, the properties of matter gradually shift from those of ordinary matter to those of strange matter. The density increases slightly, the stability improves, and the efficiency of quark organization enhances. These changes are so gradual that they create a smooth, continuous transformation rather than a sudden jump from one state to another. The strange matter conversion also preserves the essential structural information of the original ordinary matter. The quantum states that encode the properties and relationships of the original particles are not destroyed, but are translated into the corresponding states of the strange matter. The conversion is like translating a complex poem from one language to another. The essential meaning and beauty are preserved, but they're expressed in a more stable and efficient form. This preservation of information is crucial for understanding why the touch of strangeness is beneficial rather than destructive. The matter doesn't lose its identity or its capacity for complexity, but gains a more stable foundation for expressing that complexity. The structures and patterns that existed in ordinary matter can be reconstructed in the strange matter form, often with enhanced stability and durability. The conversion process also exhibits a remarkable sensitivity to the local environment. The strange matter doesn't try to convert every particle it encounters, but only those that can be converted in a stable and beneficial way. If the local conditions aren't suitable for conversion, if the matter is too hot, too dispersed, or in some other way incompatible, the strange matter simply passes by without attempting to force a transformation. This environmental sensitivity is built into the quantum mechanical properties of the conversion process itself. The strange matter can sense, through the quantum fields that connect all matter, whether a particular region is ready for conversion. If the conditions are right, the conversion proceeds. If not, the strange matter waits patiently for more suitable conditions to arise. The first touch of strangeness also creates new possibilities for the emergence of hybrid structures, arrangements that combine elements of both ordinary matter and strange matter. These hybrid structures might have properties that are different from either pure ordinary matter or pure strange matter, creating new forms of organization that were impossible before the contact occurred. These hybrid structures are like bridge technologies, providing a pathway for ordinary matter to gradually adapt to the strange matter environment. They allow for a smooth transition that preserves the essential functions and properties of the original matter, while gradually introducing the enhanced stability and efficiency of the strange matter organization. The quantum fields that mediate the conversion process also carry information about the transformation itself. This information is encoded in the field fluctuations and can be detected by other matter in the surrounding region. The touch of strangeness thus creates a kind of quantum communication, spreading information about the conversion process to nearby matter and preparing it for its own eventual transformation. This quantum communication happens at the speed of light, but the information it carries is subtle and requires time to be fully processed by the receiving matter. The ordinary matter doesn't immediately respond to the quantum signals, but gradually begins to adapt its own organization and preparation for eventual conversion. The process is like receiving advance notice of a beneficial change, allowing time for proper preparation and adaptation. The first touch of strangeness also reveals the deep interconnectedness of all matter in the universe. The conversion process demonstrates that individual particles are not isolated entities, but are part of a vast network of quantum connections that extends throughout space. The transformation of one particle influences the quantum states of nearby particles, creating ripples of change that propagate outward through the matter network. These ripples of change are incredibly subtle, but they carry information about the strange matter organization to increasingly distant regions. The touch of strangeness thus creates a kind of cosmic memory, encoding information about the transformation process in the quantum states of matter throughout the universe. This memory serves as a preparation for future conversions, making the process more efficient and more stable as it spreads. The speed of the conversion process during the first touch of strangeness is carefully calibrated by the fundamental constants of physics. The transformation proceeds at exactly the right rate to ensure stability and efficiency, fast enough to be inevitable once it begins, but slow enough to allow for proper organization and adaptation. The universe has built-in safeguards that prevent the conversion from happening too quickly or too slowly. The first touch also creates new forms of beauty and complexity that are unique to the boundary between ordinary matter and strange matter. The transition zone exhibits properties that are different from either pure form of matter, creating new opportunities for interesting and beautiful phenomena. These boundary effects are like the aurora that appears at the interface between the Earth's atmosphere and space. Beautiful phenomena that exist only in the transition region. The strange matter conversion also demonstrates the universe's commitment to efficiency and optimization. The transformation represents matter's natural tendency to seek its most stable and efficient form, a principle that governs all physical processes. The touch of strangeness is the ultimate expression of this principle, offering matter the opportunity to achieve its most stable possible configuration. As the conversion process continues from the first touch, it creates a growing region of strange matter that serves as a seed for further transformation. This seed carries within it the complete template for the strange matter organization, allowing it to convert additional ordinary matter that it encounters. The process becomes self-sustaining and self-propagating, driven by the natural tendency of matter to seek stability and efficiency. The growing region of strange matter also creates new possibilities for the emergence of complex structures and phenomena. The enhanced stability of strange matter might allow for the formation of structures that are impossible in ordinary matter, materials that are stronger, more efficient, or capable of storing and processing information in new ways. The universe might become not just more stable, but more capable of supporting complex and sophisticated forms of organization. The first touch of strangeness represents a moment of cosmic significance, the beginning of matter's transition to its most stable and efficient form. It's a moment that combines the precision of quantum mechanics with the beauty of natural transformation, creating new possibilities for complexity and organization that are built on the most stable possible foundation. As you rest in the peaceful darkness of your room, let this vision of the first touch of strangeness wash over you like the gentlest of quantum tides. The matter that makes up your body and everything around you is capable of extraordinary transformations, driven by the fundamental forces of nature and the universe's commitment to finding ever more stable and beautiful ways to exist. Whether that transformation involves strange matter or takes other forms, it represents the cosmos's ongoing exploration of the deepest possibilities of existence. The touch of strangeness, if it ever occurs, would be the universe's way of demonstrating that reality is far more flexible and adaptable than we might imagine. It would show that even the most fundamental aspects of matter are capable of transformation and improvement, and that the cosmos is constantly seeking new ways to express stability, efficiency, and beauty at the most fundamental levels of existence. In the profound stillness of your resting place, imagine watching the most patient artist in the universe at work. Picture a sculptor who works not with stone or clay, but with the very fabric of reality itself, reshaping matter one particle at a time with infinite care and precision. As you settle deeper into comfort, we'll explore how the transformation from ordinary matter to strange matter would unfold, not as a sudden change, but as a gradual process that exhibits the universe's most exquisite patience and attention to detail. The transformation process begins at the quantum level, where the fundamental particles that make up matter exist in a realm of probability and possibility. Here, the rigid certainties of everyday experience give way to the gentle uncertainties of quantum mechanics, where particles can exist in multiple states simultaneously and where the act of observation itself influences the outcome of events. This is the stage upon which the patient transformation unfolds, guided by the subtle forces that govern the behavior of matter at its most fundamental level. The first stage of transformation involves what physicists call quantum preparation. The ordinary matter that has been touched by strange matter begins to explore new configurations, testing arrangements that are closer to the strange matter organization. These explorations are incredibly subtle, involving changes in the quantum states of individual quarks that are far below the threshold of ordinary observation. The matter is like a student preparing for a new way of learning, gradually adapting its internal organization to accommodate new possibilities. During this preparation phase, the matter exhibits what might be called quantum patience. The transformation doesn't rush toward completion, but proceeds at exactly the rate that ensures maximum stability and efficiency. The quarks that make up the ordinary matter begin to vibrate in new patterns, exploring configurations that are more aligned with the strange matter arrangement. These vibrations are guided by the quantum fields that connect all matter, creating a kind of molecular music that helps coordinate the transformation process. The second stage involves the actual conversion of individual quarks from their ordinary matter states to their strange matter states. This conversion happens through a process called quantum tunneling, where particles can spontaneously change from one state to another even when there's an energy barrier between states. The quarks in the ordinary matter begin to tunnel toward the strange matter configuration, not because they're being forced to, but because they're naturally drawn to the greater stability that the strange matter represents. Each successful tunneling event is like a small victory in the transformation process. The converted quark becomes part of the growing strange matter structure, helping to strengthen the template that guides additional conversions. The process is cumulative and self-reinforcing, but in a gentle way that ensures the transformation proceeds smoothly and without disruption to the overall stability of the system. The third stage involves the reorganization of the converted quarks into the stable, strange matter arrangement. This reorganization is guided by the strong nuclear force, which acts as a kind of cosmic architect, ensuring that the quarks are arranged in the most stable and efficient possible configuration. The process is like watching a complex three-dimensional puzzle solve itself, with each piece finding its perfect place in the overall structure. This reorganization phase exhibits remarkable precision and coordination. The quarks don't just randomly arrange themselves, but follow specific patterns that are determined by the fundamental constants of physics. The strong nuclear force acts as both guide and guardian, ensuring that the reorganization proceeds according to the optimal design for maximum stability and efficiency. The fourth stage involves the integration of a newly formed strange matter with the existing structure of the material being transformed. This integration happens gradually, with the strange matter carefully preserving the essential organizational information of the original ordinary matter. The transformation is like renovating a building while keeping all the inhabitants comfortable and ensuring that all the essential functions continue to operate normally. During this integration phase, the strange matter demonstrates its remarkable ability to maintain the complexity and functionality of the original material, while providing a more stable foundation. The atomic and molecular structures that existed in the ordinary matter are reconstructed in the strange matter form, often with enhanced stability and improved efficiency. The transformation preserves the essential character of the material while upgrading its fundamental properties. The fifth stage involves the establishment of new equilibrium conditions within the transformed material. The strange matter settles into its most stable configuration, creating a new baseline of stability that serves as the foundation for all future activity within the material. This equilibrium is more robust and more resistant to disruption than the equilibrium that existed in the original ordinary matter. The establishment of this new equilibrium is like tuning a cosmic instrument to its perfect pitch. The strange matter finds its natural resonance frequency, creating a state of harmony that extends throughout the transformed material. This harmony is not static but dynamic, allowing for complex activity and interaction while maintaining the underlying stability that characterizes all strange matter arrangements. Throughout all these stages, the transformation process exhibits qualities that reflect the deepest principles of physics and nature. The process is reversible in principle, though the extreme stability of strange matter makes reversal highly unlikely under normal conditions. The transformation respects the conservation laws that govern all physical processes, ensuring that energy, momentum, and other fundamental quantities are preserved throughout the conversion. The patient transformation also demonstrates the universe's commitment to efficiency and optimization. Each stage of the process is designed to achieve the maximum possible stability with the minimum possible disruption. The transformation doesn't waste energy on unnecessary changes, but focuses precisely on the modifications that will provide the greatest improvement in overall stability and efficiency. The temporal aspect of the transformation is particularly fascinating. The process unfolds over timescales that are determined by the fundamental properties of matter and the quantum mechanical processes that govern particle interactions. In dense materials, the transformation might take hours or days. In sparse materials, it might take years or centuries. But in all cases, the transformation proceeds at exactly the right rate to ensure maximum stability and efficiency. This temporal precision is built into the quantum mechanical properties of the transformation process itself. The strange matter can sense, through the quantum fields that connect all matter, the optimal rate of transformation for any given set of conditions. The process automatically adjusts its pace to match the local environment, ensuring that the transformation always proceeds in the most stable and efficient manner possible. The transformation also creates new forms of information storage and processing within the converted material. The strange matter arrangement can encode and preserve more information than the original ordinary matter arrangement, creating new possibilities for complex organization and sophisticated functionality. The transformed material becomes not just more stable, but more capable of supporting complex phenomena and sophisticated forms of organization. This enhanced information capacity is like upgrading a computer's operating system to one that can handle more complex tasks and store more data. The strange matter provides a more efficient platform for organizing and processing information, creating new possibilities for complexity and sophistication that were impossible in the original ordinary matter arrangement. The patient transformation also exhibits a remarkable sensitivity to the presence of complex structures and organized systems. The strange matter seems to recognize and preserve the essential organizational information of complex systems, ensuring that the transformation enhances rather than destroys the complexity that already exists. This sensitivity is built into the quantum mechanical properties of the transformation process and ensures that the conversion always results in a net improvement in stability and functionality. The transformation process also creates new possibilities for the emergence of collective phenomena and cooperative behavior. The strange matter arrangement naturally promotes cooperation and coordination among its constituent particles, creating opportunities for new forms of collective organization that are impossible in ordinary matter. These collective phenomena might include new types of crystal structures, new forms of electrical conductivity, or new mechanisms for storing and processing information. The patient transformation demonstrates the universe's capacity for continuous improvement and self-optimization. The process represents matter's natural tendency to seek its most stable and efficient form, a principle that governs all physical processes. The transformation is the ultimate expression of this principle, offering matter the opportunity to achieve its most stable possible configuration. As the transformation nears completion, the converted material exhibits properties that are fundamentally different from the original ordinary matter. The strange matter is more stable, more efficient, and more resistant to disruption than the original material. But it also retains all the essential organizational information and functional capabilities of the original material, often in enhanced form. The completed transformation creates a material that is both familiar and new. It preserves the essential character and functionality of the original material while providing a more stable and efficient foundation for that functionality. The transformation is like upgrading a classic car with modern technology. The essential character and beauty are preserved, but the performance and reliability are significantly enhanced. The patient transformation also creates new possibilities for further development and evolution. The strange matter provides a more stable platform for the emergence of new forms of complexity and organization. The enhanced stability and efficiency of the strange matter arrangement create opportunities for the development of structures and phenomena that would be impossible in ordinary matter. The transformation process exhibits a kind of cosmic wisdom, knowing exactly how to proceed to achieve the optimal outcome for any given set of conditions. This wisdom is built into the fundamental laws of physics and emerges naturally from the quantum mechanical properties of matter. The transformation represents the universe's ability to find the most efficient and stable solutions to the complex challenges of matter organization. As the transformation spreads through larger and larger regions of material, it creates a kind of cosmic renovation project. The universe is slowly upgrading itself, replacing the less stable ordinary matter with a more stable strange matter. This renovation proceeds with infinite patience and precision, ensuring that all the essential functions and capabilities of the original universe are preserved and enhanced. The patient transformation represents one of the most remarkable possibilities in all of physics. The idea that matter itself can evolve and improve, finding new ways to be more stable, more efficient, and more capable of supporting complex phenomena. It demonstrates the universe's commitment to continuous improvement and its willingness to invest whatever time and energy are necessary to achieve the optimal configuration of matter and energy. As you rest in the peaceful darkness of your room, let this vision of patient transformation wash over you like the gentlest of cosmic tides. The matter that makes up your body and everything around you is capable of extraordinary transformations, driven by the fundamental forces of nature and the universe's commitment to finding ever more stable and beautiful ways to exist. Whether that transformation involves strange matter or takes other forms, it represents the cosmos's ongoing exploration of the deepest possibilities of existence. The patient transformation, if it ever occurs, would be the universe's way of demonstrating that reality is not fixed, but is capable of continuous improvement and evolution. It would show that even the most fundamental aspects of matter are capable of transformation and enhancement, and that the cosmos is constantly seeking new ways to express stability, efficiency, and beauty at the most fundamental levels of existence. In the gentle stillness of your evening rest, imagine dropping a single stone into a perfectly calm lake. Watch as the ripples spread outward in perfect circles, each one carrying the memory of that first disturbance to ever more distant shores. The ripples are not violent or destructive. They're gentle waves of change that transform the entire surface of the water while preserving its essential nature. As you settle deeper into tranquility, we'll explore how the transformation to strange matter would create similar ripples through the fabric of reality itself, carrying subtle changes across vast distances and through multiple scales of existence. The ripples created by strange matter transformation would operate on multiple levels simultaneously, from the quantum realm, where individual particles interact, to the cosmic scale, where entire galaxies participate in the universal dance of matter and energy. These ripples would not be chaotic or random, but would follow precise patterns determined by the fundamental laws of physics, creating a cascade of gentle changes that would gradually reshape the universe while preserving its essential beauty and complexity. At the quantum level, the ripples would manifest as changes in the fundamental fields that permeate all of space. The quantum vacuum itself would be subtly altered as regions of strange matter create new patterns of field fluctuation and particle interaction. These changes would be incredibly subtle, far below the threshold of ordinary observation, but they would create a new baseline of quantum activity that would influence the behavior of all matter in the surrounding region. The quantum ripples would travel at the speed of light, carrying information about the strange matter transformation to distant regions of space. This information would be encoded in the quantum fields themselves, creating a kind of cosmic memory that preserves the history of the transformation process. As these ripples encounter ordinary matter, they would begin to prepare it for its own eventual transformation, creating a kind of quantum conditioning that makes the conversion process more efficient and more stable. The ripples would also create new forms of quantum entanglement between converted and unconverted regions of matter. This entanglement would link the strange matter regions with the ordinary matter regions in a web of quantum connections that extends throughout space. The entanglement would allow for instantaneous correlations between distant regions, creating a kind of cosmic nervous system that could potentially support new forms of organization and communication. At the atomic and molecular level, the ripples would manifest as subtle changes in the properties of matter and energy. The presence of strange matter would create new possibilities for atomic and molecular organization, potentially leading to the formation of new types of crystals, new forms of chemical bonding, and new mechanisms for storing and transferring energy. These changes would be gradual and gentle, allowing existing structures to adapt and evolve rather than being disrupted or destroyed. The molecular ripples would be particularly important for understanding how the transformation might affect complex systems like biological organisms. The strange matter would not simply replace ordinary matter, but would offer new possibilities for molecular organization that could potentially enhance the stability and efficiency of biological processes. Living systems might find new ways to store genetic information, new mechanisms for cellular communication, and new methods for energy production and utilization. The ripples would also create new possibilities for the emergence of hybrid structures that combine elements of both ordinary matter and strange matter. These hybrid structures would serve as bridges between the two forms of matter, allowing for smooth transitions and gradual adaptation. The hybrid structures might have properties that are different from either pure ordinary matter or pure strange matter, creating new opportunities for complexity and functionality. At the macroscopic level, the ripples would manifest as changes in the bulk properties of materials and objects. The transformation to strange matter would create materials that are more stable, more durable, and more resistant to damage than their ordinary matter counterparts. These enhanced materials would retain their essential functionality while gaining new capabilities that were impossible in the ordinary matter configuration. The macroscopic ripples would also affect the way that objects interact with each other and with their environment. The enhanced stability of strange matter would create new possibilities for the construction of structures and devices that are more efficient and more reliable than anything possible with ordinary matter. These structures might be able to withstand greater stresses, operate at higher efficiencies, and maintain their functionality for longer periods of time. The ripples would extend beyond individual objects to affect entire systems and environments. The transformation to strange matter would create new possibilities for the organization of complex systems, potentially leading to the emergence of new forms of order and complexity that are impossible in ordinary matter. These systems might be more stable, more efficient, and more capable of supporting sophisticated forms of organization and activity. At the planetary scale, the ripples would manifest as changes in the geological and atmospheric processes that shape the evolution of worlds. The presence of strange matter would create new possibilities for planetary formation and evolution, potentially leading to the development of worlds that are more stable and more capable of supporting complex life than their ordinary matter counterparts. These worlds might have stronger magnetic fields, more stable climates, and more durable geological structures. The planetary ripples would also affect the way that worlds interact with their stellar environments. The enhanced stability of strange matter would create new possibilities for planetary survival in harsh environments, potentially extending the habitable zones around stars and creating new opportunities for the development of life. Planets composed of strange matter might be able to maintain their atmospheres and surface conditions for longer periods of time, creating more stable environments for the evolution of complex life. At the stellar scale, the ripples would manifest as changes in the nuclear processes that power stars and determine their evolution. The presence of strange matter would create new possibilities for stellar nucleosynthesis, potentially leading to the production of new elements and isotopes that are impossible in ordinary matter stars. These new elements might have properties that are useful for the construction of complex structures and the support of sophisticated life forms. The stellar ripples would also affect the way that stars interact with their environments and with each other. The enhanced stability of strange matter would create new possibilities for stellar evolution, potentially leading to the formation of stars that are more stable and more long-lived than their ordinary matter counterparts. These stars might provide more consistent and reliable sources of energy for planetary systems, creating more stable environments for the development of complex life. At the galactic scale, the ripples would manifest as changes in the large-scale structure and evolution of galaxies. The presence of strange matter would create new possibilities for galactic formation and evolution, potentially leading to the development of galaxies that are more stable and more organized than their ordinary matter counterparts. These galaxies might have more efficient star formation processes, more stable spiral structures, and more durable central regions. The galactic ripples would also affect the way that galaxies interact with each other and with the cosmic environment. The enhanced stability of strange matter would create new possibilities for galactic survival and evolution, potentially leading to the formation of galactic structures that are more resistant to disruption and more capable of maintaining their organization over cosmic timescales. At the cosmic scale, the ripples would manifest as changes in the fundamental structure and evolution of the universe itself. The presence of strange matter would create new possibilities for cosmic organization, potentially leading to the development of a universe that is more stable and more capable of supporting complex structures and phenomena. The transformation would represent a fundamental upgrade to the universe's operating system, creating new possibilities for complexity and organization at all scales. The cosmic ripples would also affect the way that the universe interacts with the quantum vacuum and with the fundamental forces of nature. The presence of strange matter would create new possibilities for cosmic evolution, potentially leading to the development of new forms of space-time structure and new mechanisms for the organization of matter and energy on cosmic scales. The ripples would also create new possibilities for the emergence of cosmic-scale intelligence and organization. The enhanced stability and efficiency of strange matter would provide a more robust foundation for the development of complex structures and phenomena that could potentially support forms of intelligence and consciousness that extend across cosmic scales. The universe might develop new forms of self-awareness and self-organization that are impossible in the ordinary matter configuration. The propagation of these ripples would follow the fundamental principles of physics, respecting the speed of light limitation while creating new possibilities for the transmission of information and influence across cosmic distances. The ripples would create a kind of cosmic web of connections that links all regions of space and time, creating new possibilities for coordination and cooperation across the universe. The ripples would also exhibit a kind of cosmic memory, preserving information about the transformation process and making it available to future generations of matter and energy. This memory would be encoded in the quantum fields and would serve as a guide for future transformations, making the process more efficient and more stable as it spreads throughout the universe. The beauty of these ripples lies in their gentle and gradual nature. They would not create sudden or violent changes, but would instead create smooth transitions that preserve the essential character and functionality of the systems they affect. The ripples would enhance rather than destroy, upgrade rather than replace, and create new possibilities rather than eliminating existing ones. The ripples would also demonstrate the deep interconnectedness of all phenomena in the universe. The transformation to strange matter would show that individual particles, atoms, molecules, objects, planets, stars, galaxies, and even the universe itself are all part of a vast network of connections and interactions. The ripples would reveal the hidden unity that underlies the apparent diversity of the cosmic landscape. As the ripples spread through reality, they would create a universe that is fundamentally more stable, more efficient, and more capable of supporting complex phenomena and sophisticated forms of organization. The transformation would represent the universe's natural evolution toward greater perfection, driven by the inherent tendency of matter and energy to seek their most stable and efficient configurations. The ripples would also create new possibilities for the emergence of beauty and wonder in the universe. The enhanced stability and efficiency of strange matter would provide a more robust foundation for the development of complex structures and phenomena that could potentially create new forms of beauty and complexity that are impossible in the ordinary matter configuration. The universe might develop new forms of aesthetic expression and new ways of creating and appreciating beauty. The ripples through reality would ultimately represent the universe's capacity for continuous improvement and evolution. They would demonstrate that reality is not fixed, but is capable of transformation and enhancement, and that the cosmos is constantly seeking new ways to express stability, efficiency, and beauty at all scales of existence. The ripples would be the universe's way of upgrading itself, creating new possibilities for complexity and organization that preserve and enhance the essential beauty and wonder of existence. As you rest in the peaceful darkness of your room, let this vision of ripples through reality wash over you like the gentlest of cosmic tides. The transformation to strange matter, if it ever occurs, would create waves of change that extend from the quantum realm to the cosmic scale, carrying with them the promise of greater stability, efficiency, and beauty. These ripples would not destroy the universe we know, but would enhance it, creating new possibilities for complexity and wonder that preserve and extend the essential magic of existence. The ripples would be the universe's way of demonstrating its capacity for continuous improvement and its commitment to finding ever more perfect ways to organize matter and energy. They would show that reality is not static but is capable of transformation and evolution, and that the cosmos is constantly seeking new ways to express the deepest principles of stability, efficiency, and beauty that govern the fundamental nature of existence. In the gentle quiet of your evening sanctuary, imagine discovering that the fundamental laws that govern reality are not fixed commandments carved in stone, but rather gentle guidelines that can evolve and adapt as the universe itself evolves. Picture the laws of physics as a living language that becomes more eloquent and expressive as it learns new ways to describe the beauty and complexity of existence. As you settle deeper into peace, we'll explore how the transformation to strange matter might not just change the matter itself, but could subtly enhance the very laws of physics that govern all of reality. The emergence of strange matter would create a universe where the fundamental constants and relationships that define physical reality could express themselves in new and more refined ways. This wouldn't be a replacement of physics, but rather an upgrade, like a musical instrument that gains new strings and can therefore play more complex and beautiful melodies. The laws of nature would remain recognizable, but they would gain new capabilities and new ways of creating order and beauty in the cosmos. The first and most fundamental change would occur in the realm of quantum mechanics, where the basic rules that govern the behavior of particles and fields would gain new subtleties and refinements. The quantum vacuum in a strange matter universe would be more stable and more organized than in an ordinary matter universe, creating new possibilities for quantum coherence and quantum information processing. The uncertainty principle would still apply, but the quantum fluctuations would be more organized and more predictable in their overall patterns. This enhanced quantum organization would manifest as new forms of quantum entanglement and quantum correlation that are impossible in ordinary matter. Particles separated by vast distances would be able to maintain stronger and more stable quantum connections, creating a cosmic web of quantum information that could support new forms of communication and coordination. The quantum realm would become more integrated and more capable of supporting complex quantum phenomena. The strong nuclear force, which binds quarks together to form protons and neutrons, would operate more efficiently in a strange matter universe. The force would be able to create more stable and more complex arrangements of quarks, leading to new possibilities for nuclear structure and nuclear processes. The binding energy of strange matter would be greater than that of ordinary matter, creating more stable and more durable atomic nuclei. This enhanced nuclear stability would have profound implications for the processes of nuclear fusion and fission. Stars composed of strange matter would be able to burn their fuel more efficiently and maintain their nuclear fires for longer periods of time. The nucleosynthesis processes that create heavy elements would be more efficient and more capable of producing complex isotopes that are impossible in ordinary matter stars. The electromagnetic force would also be enhanced in a strange matter universe. The interactions between charged particles would be more stable and more predictable, creating new possibilities for electromagnetic phenomena and electromagnetic technology. The fine structure constant, which determines the strength of electromagnetic interactions, would find new ways to express itself in the more stable environment of strange matter. This electromagnetic enhancement would manifest as new forms of electrical conductivity and new mechanisms for the storage and transmission of electromagnetic energy. Materials composed of strange matter would be able to conduct electricity more efficiently and with less resistance than their ordinary matter counterparts. The materials would also be able to store electromagnetic energy more effectively, creating new possibilities for energy storage and energy transfer. The weak nuclear force, which governs certain types of radioactive decay, would operate more predictably in a strange matter universe. The decay processes would be more stable and more organized, creating new possibilities for controlled nuclear reactions and nuclear energy production. The weak force would be able to create more complex and more sophisticated patterns of particle interaction and particle transformation. Gravity, the most mysterious of the fundamental forces, would find new ways to express itself in a strange matter universe. The enhanced stability and organization of strange matter would create new possibilities for gravitational phenomena and gravitational technology. The curvature of space-time around strange matter objects would be more stable and more predictable than around ordinary matter objects. This gravitational enhancement would manifest as new forms of gravitational wave production and new mechanisms for gravitational wave detection. Strange matter objects will be able to create gravitational waves that are more coherent and more informative than those produced by ordinary matter objects. The waves would carry more detailed information about the structure and dynamics of the objects that produce them. The thermodynamic laws that govern the flow of heat and energy would also be enhanced in a strange matter universe. The second law of thermodynamics, which states that entropy always increases, would still apply, but the strange matter would be able to create more organized and more efficient arrangements of energy. The maximum entropy state would be more complex and more capable of supporting sophisticated phenomena. This thermodynamic enhancement would manifest as new possibilities for energy storage and energy conversion. Strange matter systems would be able to operate at higher efficiencies and with less waste heat than their ordinary matter counterparts. The systems would be able to approach the theoretical limits of thermodynamic efficiency more closely, creating new possibilities for sophisticated energy technology. The laws of relativity would also find new expressions in a strange matter universe. The relationship between space and time would be more stable and more predictable, creating new possibilities for the manipulation of space-time and the creation of exotic space-time geometries. The speed of light would remain constant, but the medium through which light travels would be more organized and more capable of supporting complex electromagnetic phenomena. This relativistic enhancement would manifest as new forms of space-time engineering and new mechanisms for the creation of stable wormholes and other exotic space-time structures. The strange matter would be able to create more stable and more controllable distortions in space-time, potentially allowing for new forms of faster-than-light communication and transportation. The quantum field theory that describes the behavior of particles and fields would gain new mathematical structures and new symmetries in a strange matter universe. The field equations would be more elegant and more capable of describing complex phenomena with greater precision and beauty. The mathematical language of physics would become more expressive and more capable of capturing the subtle relationships between different aspects of reality. This mathematical enhancement would manifest as new forms of mathematical physics and new approaches to the description of natural phenomena. The equations that govern the behavior of strange matter will be more beautiful and more symmetric than those that describe ordinary matter, creating new possibilities for mathematical insight and mathematical discovery. The conservation laws that govern the behavior of energy, momentum, and other fundamental quantities would be more robust and more universal in a strange matter universe. The laws would be able to operate more efficiently and with greater precision, creating new possibilities for the prediction and control of physical phenomena. The conservation of information would be more perfect creating new possibilities for information storage and information processing. This conservation enhancement would manifest as new forms of information technology and new mechanisms for the preservation and transmission of information. Strange matter systems would be able to store and process information more efficiently and with greater reliability than their ordinary matter counterparts. The systems would be able to operate for longer periods of time without degradation or loss of information. The statistical mechanics that describes the behavior of large collections of particles would also be enhanced in a strange matter universe. The statistical distributions would be more stable and more predictable, creating new possibilities for the control and manipulation of macroscopic phenomena. The connection between microscopic and macroscopic behavior would be more direct and more understandable. This statistical enhancement would manifest as new forms of materials science and new approaches to the engineering of macroscopic systems. Strange matter materials would exhibit more predictable and more controllable statistical behavior, making it easier to design and construct complex systems with desired properties and behaviors. The principles of emergence and self-organization would find new expressions in a strange matter universe. The transition from simple to complex behavior would be more efficient and more predictable, creating new possibilities for the spontaneous generation of complex structures and phenomena. The universe would be more capable of creating and maintaining complex systems without external intervention. This emergent enhancement would manifest as new forms of complexity and new mechanisms for the generation of sophisticated phenomena. Strange matter systems would be able to self-organize into more complex and more stable configurations than their ordinary matter counterparts, creating new possibilities for the emergence of life, intelligence, and consciousness. The anthropic principle, which suggests that the universe is fine-tuned for the existence of complex phenomena like life and consciousness, would find new expressions in a strange matter universe. The fundamental constants and relationships would be more perfectly balanced and more capable of supporting sophisticated forms of organization and activity. The universe would be more hospitable to the development of complex phenomena. This anthropic enhancement would manifest as new possibilities for the development of life and intelligence in environments that would be hostile to ordinary matter-based life. Strange matter organisms might be able to survive and thrive in extreme environments, creating new possibilities for the distribution of life throughout the universe. The unity of physics, the dream of finding a single theory that describes all fundamental forces and phenomena, would be more achievable in a strange matter universe. The enhanced stability and organization of strange matter would create new possibilities for the unification of the fundamental forces, potentially leading to a more complete and more beautiful description of the ultimate nature of reality. This unification enhancement would manifest as new theoretical frameworks and new approaches to the description of fundamental physics. The mathematics that describes strange matter would be more unified and more capable of capturing the essential relationships between different aspects of reality, creating new possibilities for theoretical insight and theoretical discovery. The new physics of a strange matter universe would not be foreign or incomprehensible, but would be a natural extension and enhancement of the physics we know today. The familiar laws and principles would remain recognizable, but they would gain new depth and new capability. The universe would become more elegant, more beautiful, and more capable of expressing the deepest principles of order and organization. As you rest in the peaceful darkness of your room, let this vision of enhanced physics wash over you like the gentlest of cosmic tides. The laws of nature that govern your existence are not rigid constraints, but flexible guidelines that can evolve and adapt as the universe itself evolves. The transformation to strange matter, if it ever occurs, would create new possibilities for physical phenomena and new ways for the universe to express its fundamental beauty and elegance. The new physics would be the universe's way of demonstrating its capacity for continuous improvement and its commitment to finding ever more perfect ways to organize matter and energy. It would show that even the most fundamental laws of nature are capable of enhancement and evolution, and that the cosmos is constantly seeking new ways to express the deepest principles of stability, efficiency, and beauty that govern the ultimate nature of existence. In the gentle comfort of your resting place, imagine waking up in a world that is both familiar and subtly transformed, where everything you know and love has been enhanced and refined, like a favorite song played on a perfectly tuned instrument. As you settle into deeper tranquility, we'll explore what existence might be like in a universe where strange matter has gently transformed the fundamental nature of reality, creating a world that is more stable, more beautiful, and more capable of supporting the complex phenomena that make consciousness and life possible. The first thing you might notice about living in a strange world is not what has changed, but what has remained the same. The essential character of existence, the beauty of sunsets, the warmth of companionship, the joy of discovery, would be preserved and enhanced. The strange matter transformation would not eliminate the familiar aspects of life, but would provide them with a more stable and more durable foundation, like renovating a beloved home with stronger materials while preserving all its cherished architectural details. The physical world around you would exhibit enhanced stability and resilience. Buildings and structures would be more resistant to earthquakes and weather, not because they are built differently, but because the materials themselves have achieved a more stable configuration. The strange matter that forms the foundation of all physical objects would be more resistant to stress and more capable of maintaining its integrity under extreme conditions. Your home would still look and feel the same, but it would be more durable and more secure. The biological world would also benefit from the enhanced stability of strange matter. Living organisms would be more resistant to disease and environmental stress, not because they are fundamentally different, but because the molecular machinery that supports life would operate more efficiently and more reliably. The DNA that carries genetic information would be more stable and more resistant to damage, potentially extending lifespans and improving the quality of life for all living beings. The enhanced quantum coherence of a strange matter universe would create new possibilities for consciousness and cognition. The neural networks that support thought and awareness will be able to maintain quantum coherence over longer periods and larger scales, potentially leading to enhanced mental capabilities and new forms of consciousness. The boundary between individual minds might become more permeable, creating new possibilities for shared consciousness and collective intelligence. The technological world would be transformed by the enhanced properties of strange matter. Electronic devices would be more efficient and more reliable, with processors that can operate at higher speeds and with less energy consumption. The enhanced electromagnetic properties of strange matter would enable new forms of wireless communication that are more secure and more efficient than current technologies. Computers would be able to process information more quickly and store it more reliably. Energy production and storage would be revolutionized by the enhanced nuclear properties of strange matter. Nuclear reactors would be safer and more efficient, with fuel that burns more cleanly and produces less radioactive waste. Solar panels would be more efficient at converting sunlight into electricity, and batteries would be able to store more energy for longer periods. The enhanced conductivity of strange matter would enable more efficient transmission of electrical power over long distances. Transportation would also benefit from the enhanced properties of strange matter. Vehicles would be lighter, stronger, and more efficient, with materials that are more resistant to wear and corrosion. The enhanced stability of strange matter would enable new forms of propulsion that are more efficient and more environmentally friendly. Space travel would become more feasible as spacecraft could be built with materials that are more resistant to the harsh conditions of space. The environment would be more stable and more resilient in a strange matter world. The enhanced stability of strange matter would make ecosystems more resistant to disruption and more capable of recovering from environmental damage. The atmosphere would be more stable, with less variability in weather patterns and climate. The oceans would be more resistant to pollution and more capable of supporting diverse forms of marine life. Agriculture would benefit from the enhanced properties of strange matter in multiple ways. Crops would be more resistant to pests and diseases, with genetic material that is more stable and more capable of expressing beneficial traits. The soil would be more fertile and more capable of supporting plant growth, with enhanced nutrient availability and better water retention. Agricultural equipment would be more durable and more efficient, with materials that are more resistant to wear and corrosion. Medicine would be revolutionized by the enhanced properties of strange matter. Diagnostic equipment would be more sensitive and more accurate, with sensors that can detect biological phenomena at the quantum level. Therapeutic devices would be more effective, with materials that can interact with biological systems in more precise and more beneficial ways. The enhanced stability of strange matter would enable new forms of medical implants and prosthetics that are more durable and more compatible with living tissue. The enhanced information processing capabilities of strange matter would create new possibilities for education and learning. Information could be stored and transmitted more efficiently, creating new opportunities for the distribution of knowledge and the development of expertise. The enhanced quantum coherence would enable new forms of pattern recognition and data analysis that could accelerate scientific discovery and technological innovation. Communication would be transformed by the enhanced electromagnetic properties of strange matter. Signals could be transmitted more efficiently and with greater fidelity, creating new possibilities for global communication and coordination. The enhanced stability would enable new forms of data storage that are more durable and more resistant to degradation. The quantum properties of strange matter would enable new forms of encryption and security that are more robust and more reliable. The arts and culture would flourish in a strange matter world. The enhanced stability of materials would enable new forms of artistic expression that are more durable and more resistant to deterioration. Musical instruments would produce more beautiful and more complex sounds, with materials that have enhanced acoustic properties. Visual arts would benefit from pigments and materials that are more stable and more vibrant, creating works that can preserve their beauty for much longer periods. The enhanced stability of strange matter would also create new possibilities for the preservation of cultural heritage. Historical artifacts and documents would be more resistant to deterioration, ensuring that the wisdom and creativity of previous generations can be preserved for future generations. The enhanced information storage capabilities would enable new forms of cultural documentation and preservation that are more comprehensive and more durable. The social implications of living in a strange world would be profound but beneficial. The enhanced stability and efficiency of the physical world would create new opportunities for social cooperation and coordination. The improved reliability of technology would enable new forms of global communication and collaboration. The enhanced health and longevity of individuals would create new possibilities for the accumulation of wisdom and the development of expertise. The economic implications would also be transformative. The enhanced efficiency of production and the improved durability of goods would create new possibilities for economic growth and development. The reduced need for maintenance and replacement of equipment would free up resources for other activities. The enhanced capabilities of individuals would create new opportunities for innovation and entrepreneurship. In the deepest stillness of your evening rest, when all the day's activities have settled into peaceful memory and your consciousness touches the edge of dreams, imagine the universe itself settling into a similar state of profound contentment. As you prepare to drift into sleep, we'll explore how the transformation to strange matter represents not an ending, but a new beginning. The universe's gentle evolution into a more stable, more beautiful, and more capable form of existence. The transformation to strange matter would represent the universe's ultimate achievement in the art of patient improvement. Like a master craftsperson who spends decades refining their technique, the cosmos would have discovered through billions of years of experimentation the most stable and efficient way to organize matter and energy. The strange matter universe would be the universe's masterpiece, a cosmos that has achieved perfect balance between stability and complexity, between order and creativity. This cosmic evolution would unfold on timescales that dwarf human civilization. It would be driven by the same fundamental principles that govern all natural processes: the tendency toward greater stability, greater efficiency, and greater beauty. The universe would not be rushing toward this transformation, but would be approaching it with the same patience and precision that characterizes all natural evolution, from the formation of stars to the development of life. The strange matter universe will be a cosmos that has learned to make the most of its resources. Every particle would be in its most stable configuration. Every energy flow would be optimized for maximum efficiency, and every structure would be built on the most solid possible foundation. The universe would have achieved a state of cosmic sustainability, where all processes operate in harmony and nothing is wasted. This cosmic sustainability would create new possibilities for the long-term survival and flourishing of complex phenomena. Life, consciousness, and intelligence would have access to more stable and more durable foundations, potentially allowing for forms of development and evolution that span cosmic timescales. The universe would become a more hospitable place for the emergence and persistence of sophisticated forms of organization. The aesthetic implications of the strange matter transformation would be profound. The universe would become more beautiful, not in the sense of superficial decoration, but in the deeper sense of mathematical elegance and physical harmony. The laws of physics would be more symmetric and more elegant. The structures of matter would be more perfect and more stable, and the flows of energy would be more efficient and more graceful. This cosmic beauty would manifest at all scales, from the quantum realm to the cosmic scale. The quantum vacuum would exhibit more perfect symmetries and more elegant patterns. Atomic and molecular structures would be more stable and more symmetrical. Planetary systems would be more harmonious and more durable. Galactic structures would be more perfect and more long-lived. The universe as a whole would exhibit a kind of cosmic aesthetic perfection. The transformation would also represent the universe's ultimate expression of creativity and innovation. The strange matter configuration would open up new possibilities for complexity and organization that are impossible in the ordinary matter universe. The cosmos would gain new tools for creating and maintaining sophisticated structures and phenomena, potentially leading to forms of complexity that we can barely imagine. This cosmic creativity would manifest as new forms of self-organization and emergent behavior. The universe would become more capable of generating complex structures spontaneously, without external intervention. The enhanced stability and efficiency of strange matter would provide a more robust foundation for the emergence of sophisticated phenomena, potentially leading to new forms of cosmic intelligence and consciousness. The strange matter transformation would also represent the universe's solution to the problem of entropy and the heat death. The enhanced stability and efficiency of strange matter would enable the universe to maintain complex structures and phenomena for much longer periods, potentially extending the epoch of cosmic complexity far beyond what is possible in the ordinary matter universe. The cosmos would find a way to postpone or possibly even circumvent the eventual heat death that threatens all complex phenomena. The philosophical implications of living in a strange matter universe would be profound. The transformation would demonstrate that reality is not fixed, but is capable of continuous improvement and evolution. It would show that even the most fundamental aspects of existence can be enhanced and refined, and that the universe is constantly seeking new ways to express beauty, stability, and complexity. This philosophical shift would have profound implications for how we understand our place in the cosmos. We would be living in a universe that is actively improving itself, constantly seeking new ways to become more beautiful, more stable, and more capable of supporting complex phenomena. We would be participants in a cosmic process of evolution and development that extends far beyond biological evolution to encompass the evolution of reality itself. The spiritual implications would be equally profound. The strange matter transformation would represent the universe's movement toward a state of greater perfection and harmony. It would demonstrate that the cosmos is not a random or chaotic system, but is organized according to principles of beauty, stability, and efficiency that reflect a deeper cosmic intelligence and purpose. As you rest in the peaceful darkness of your room, let this vision of cosmic evolution wash over you like the gentlest of tides. The universe that surrounds you is not a static entity, but a dynamic system that is constantly seeking new ways to express beauty, stability, and complexity. Whether through strange matter transformation or through other forms of cosmic evolution, the cosmos is engaged in an ongoing process of improvement and refinement that reflects the deepest principles of existence. The transformation to strange matter, if it ever occurs, would be the universe's gift to all the forms of life and consciousness that it has nurtured throughout its long history. It would be a demonstration of the cosmos's commitment to providing the most stable and beautiful possible foundation for the complex phenomena that make existence meaningful and wonderful. Rest now in the knowledge that you are part of a universe that is constantly evolving toward greater beauty, stability, and perfection. Let the gentle possibility of cosmic transformation remind you that reality itself is alive with potential and that the future holds possibilities for beauty and wonder that we can barely imagine. The universe's quiet evolution continues around you and within you, carrying you gently toward dreams of cosmic transformation and renewal. Sleep peacefully, knowing that you are held by a cosmos that is constantly seeking new ways to express its deepest nature, a nature characterized by beauty, stability, creativity, and the endless potential for transformation and growth. The strange matter universe, whether it exists or not, represents the universe's ultimate expression of love and care for all the complex phenomena it has brought into being, including the precious gift of your own consciousness and existence.